I've been experimenting a little bit with the Arduino logger, and I made a couple of changes that are showing some nice improvements if any of you are interested in how I'm using this. One of the things I did is I went to the clock generator, and previously I was using the clock out of that to go into my Arduino, and that's how I was basically checking for when I should read the values, was on every one of those clocks. In a previous video, I mentioned that maybe I could go to the half clock, or what the processor would use internally, which is half the speed of the clock actually coming into the system. So in this case, I'm bringing a clock in from an external source, my clock card sitting up here, into this pin here, pin 5, this EFI, so it's an external clock. And then the clock coming out of the clock generator is what's going to my processor, and would be kind of the processor external clock. And then internally, the processor uses half of that as the processor clock, half that speed. Well, on the clock generator, there's also a P clock, and that is a peripheral clock. And in this case, it is essentially synchronized with or the same as the internal processor clock as far as I understand it. So it's half the speed of clock. So I switched my Arduino to pull from P clock on the clock generator and instead of from clock. Maybe another change that I made, if I pull over this for a second, is I came in here and modified my interrupt. This is on my Arduino. Previously I was looking at the rising edge of the clock, and I knew I had to change that because I think most of the 286 processor is doing things on the falling edge of the clock. So I just changed my interrupt to look at the falling edge of the clock instead of the rising edge. So I've made those changes, and then something else I was looking at is what can I do to improve the output. So instead of just seeing all of these, what could be an instruction when it tries to decode instructions to filter out some of the noise you might have seen in my previous videos where it was showing all these other instructions that maybe weren't exactly accurate because it was just reading a data value and saying, well, if that was an instruction, this is what it might be. So I put some additional effort into maybe just filtering things out a bit so that I have a better view of what's going on. Maybe one other thing on the screen here that reminds me I did is I took my serial speed up to 921,600 BPS. Seems to be running fine at that. So this is just a Mega, Arduino Mega. I'm using USB to connect into my machine. So basically this USB serial to my serial monitor window here will be running at 921,600, and that does definitely make a difference when I start to turn up the clock speed here. Let me show you what this output is now looking like, and maybe I can show you a couple of things. Let me just get this running again. So right now what you're seeing is the latest version of what this is outputting. And maybe what I'll do is just remind you what the code looks like. I think I've got this open. So this is the code that I'm actually running, but right now it's running and it's in this loop. So basically my system starts up, I tell it to jump up to this top, disable interrupts, set up my registers, and then just get in this loop where I do a move. I say this is an address that I want to store in this B register, so it's basically a pointer to that memory address. Put this 0F0F into that memory location, read that memory location back out into a different register, and then output that register as if it was going to I/O so that we can see it over on the data bus. And that's anywhere you see the 0F0F, so the 4 off, 4 on, 4 off, 4 on is the 0F0F. And so right now it's just going through that loop. And you can see on my logger now, it's a bit more intelligent. So what it's now showing for these decodes is only the ones where there actually is something. So I'm doing a move, a move, a move, and out, and a jump. And so if I go back over here to my code, my other Visual Studio, move, 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 out, and then I guess I get down to the jump, so I should highlight that too. So this is the entire loop right there. So it is now better reflecting what's going on instead of a lot of the other noise that was in these columns here. Disregard the last column, I'm just doing some tracking of some things, and that's what this little debug label is for. And you can see now that this is seems to be working pretty well. And also I can now go to my clock speed. I'm just running off the 555 timer for now, but I'm going to turn that up to the maximum. So this is the fastest I can run off my 555, and you can see it's running through things pretty quickly here. But this Arduino debugger is keeping up, at least at this stage. And I believe when I measured this before, we were in that 250 hertz. And being that I'm using peripheral clock, it's probably half of that. So we're probably looking at 120-ish for frequency, 120 hertz. And again, if I'm just doing some initial debugging on something I'm building, this is way fast, or fast enough that I'll be able to kind of see what's going on the screen any faster, and it's not going to be very helpful unless I can write this data out to some sort of a log file and then go back and parse that, but that's not my intention to do that. So kind of some nice updates. Let me maybe temporarily just slow this down while I wait for my oscilloscope to turn on. But you can see it's running through that. I'm just seeing the indicators of what is the decoded instruction, the best that it can tell, and it seems to be working. Am I doing a RAM read, RAM write, ROM read? This goes back to what is my bus cycle, so I can go look up what the different bus cycles are in the documentation of those 4 values. I've got BHE, am I writing, am I reading, my address latching, and then a couple that help me to determine if I should be outputting data and which direction data is going. And then later you're going to start seeing some enable signals, like when I enable one of these IOs. That's probably the first one that we're going to have next, is when I enable the IO to go to the LCD. That'll throw up a flag over here to the right saying that this PPI is now active, or this PPI is active, or the math coprocessor is active, or my interrupt controller, I'm writing some configuration to it and it's active. I guess real quick, if I want to check that speed, let's see, let me just get something I can plug into ground real quick. So I am going to plug into ground here. And I just want to connect into and get a value of this right here. And so right now it's going pretty slow, but let me speed up this clock all the way. And I'm not recording this, so you're not seeing what's on my scope, but I can at least read that to you. And yeah, it's 126.4 hertz is what this is running at the moment. And so it looks like the Arduino and the logic that I have going on can keep up with that just fine. And that's, like I said, faster than I'm going to be able to keep up with if I'm realistically trying to walk through code and understand what's going on here. But I thought that was kind of interesting and thought I would just share that. Maybe if I go back to the code for a second, I'm going to turn this down for now. I'll show you how I'm approaching getting some of this done if you're interested. I do have this character array or string, this array basically of strings, I guess in this case, of all the different operations or opcodes. And so the first one is a 0, a 1, a 2, a 3, etc. These are just in order of the value of the opcodes, and pulled that data from the table that goes with the Harris documentation for the 286. And then I just added a new array of integers. And I've only filled in a few of these as samples, but this will tell me how much data is that specific opcode taking. For example, some of the moves, it takes more than just the 2 bytes for the instruction data and then the 2 bytes that follow it. Sometimes there's an additional set of information. And so I had to put in some logic that just says if you're doing a move and it's followed by 4 bytes of related parameter data, don't treat those following lines as new opcodes. That's just data that's trailing the opcode that was already in process. And so I'll fill this in with actual values, but most of them are 4, some are 6. I know it can go up more bytes than that, but what this helped me do was to really filter out some extra garbage that I didn't want to see that weren't technically opcodes. They were values being provided to one of the operations. And then in my code, I've got some basically some additional logic that just says, okay, if you're choosing to do decoding of opcodes and the opcode is still, the previous one is still being processed, in other words, it hasn't finished, don't try to decode any of its data as opcodes. And if the previous cycle was a read, then if all that stuff is true, then actually show me an opcode or try to decode the opcode. And let me see, did I close that window? I must have. Let me get that back up. And what I've noticed here as I look at this and the reason I did the logic this way, and if it was a previous read, I guess I have logic that is further down that just says here, if these signals were this way, which are the signals that indicate an instruction read, then flag it that, hey, this was an instruction read. So the next time around, the next clock cycle, I know that I'm in the middle of an instruction. And if I go to my window for my serial, and I just pause this for a second, here is the 1101 that tells me that I am doing an instruction read. And then here's where it actually does the read from the ROM, and it pulled back that, okay, you pulled back a BB00. I know between the address 0 and BHE whether I'm doing a high byte, low byte, or full double byte or a word read. And so then I can decode that. And in this case, I know that if my address 0 is a 1 and BHE is a 0, that's a high byte instruction read. And so I look at the BB, I look up into that array and say, okay, for position BB in that array, what is it? It's a move. And then in this case, that move has 6 bytes of data that goes with it. And that's what I'm showing in my little debug space over to the right, is there's 6 bytes of stuff that goes with that move. And then I kind of say, don't try to decode something again until you work your way through those 6 bytes. And so then when I got down to this one, I've got another 1101. There's also one here, but I ignore it. So even though this is an instruction read, I don't try to decode anything because I'm still processing the previous move. Then I get down to this one. It had a 1-1 prior, which tells me that I'm doing an instruction read. I finished running through it previously, so now I know I can go ahead and decode this. And then I look at this, and this one is a 0 over here and a 0 over here, so that's a full word that it's reading. And so then I decode it, and in this case, I'm decoding the C7 as a move. And then this one down here is also a move, but it's an 8B. So these are 3 different moves. There's a BB, there's a C7, and there's an 8B. And that just goes back to the code I'm using, is using 3 different moves as far as what they're doing for addressing, I guess, or how they're referencing what they're working with. And if I go back to this, and actually maybe a nice way to look at this is at the listing file that goes with it when you compile, and I don't know if I've got that open or not. Yeah, I do. Let me pull that over. So in this case, I can see I did a move like this, or actually this one down here. This is what I have in the code, this highlighted part. This is what gets put into the ROM. Here's another move. This is what got put into the ROM. Here's another move, and it got put in as this. So I got a BB, a C7, and an 8B. So 3 different moves, and basically in my code then, I can go and have it look up in here, how long am I expecting, how much data am I expecting with those different moves. And I corrected the 2 of those that had more data, and I said, yep, you got an extra 2 bytes of data that you need to read with it. But this logic, it's not anything too crazy yet, but it is giving me this result, which seems to be working pretty well. So now, to me, this is more valuable. This is much more readable. and we'll see what else I add to this moving forward. I think as I get into working with the interrupt controller and the math coprocessor and maybe even these PPIs, this debugger is going to come in pretty handy. And I'm already starting to use it to just kind of learn that when I write my assembly code, where am I messing up, how I'm supposed to use segments and the different addressing types, and making sure that I'm really understanding what the processor is doing based on the code that I put in. So I think it's going to be a nice learning tool as I get into this. Uh, I thought it was pretty interesting, so I thought I'd share it, and hopefully you got some value out of this.